Deep beneath the limestone blocks of the Great Pyramid, something extraordinary has been hiding in plain sight for over 4,000 years. In 2024, a team of international physicists made a discovery that could completely rewrite what we know about Egypt's most iconic monument. Using advanced muon detection technology, they've uncovered what appears to be an intricate network of chambers, corridors, and passages carved into the very bedrock beneath Khufu's pyramid. This isn't just another void or hidden room. This is an entire labyrinth. For decades, we've believed we understood the Great Pyramid's internal structure. 3 main chambers, a grand gallery, some relieving chambers above the king's chamber, and that mysterious subterranean chamber carved into the bedrock below. Simple, elegant, and complete. Or so we thought. But what if everything we assumed about this ancient wonder was wrong? What if the pyramid we see rising majestically from the Giza plateau is only half the story? The new Muon scans reveal something that challenges our fundamental understanding of ancient Egyptian engineering. Beneath the pyramid's base, extending deep into the natural rock, lies what can only be described as an underground complex. We're talking about passages that stretch for hundreds of meters, chambers larger than anything we've found above ground, and a network so sophisticated it suggests the ancient builders had plans far more ambitious than we ever imagined. But here's where things get really interesting. The scans show this underground network isn't random or haphazard. There's a clear pattern, a deliberate design that mirrors and extends the pyramid's geometry deep into the earth. It's as if the builders created a mirror image of their monument, one that reaches upward toward the heavens, and another that plunges downward into the underworld. Now, before we dive deeper into what these scans actually show, let me be clear about something. This discovery isn't just important because it's new. It's important because it forces us to ask questions we've never asked before. Questions about the true purpose of the Great Pyramid, about the capabilities of its builders, and about what else might be hiding beneath the sands of Giza. Throughout history, whispers and legends have suggested that the pyramids held secrets beyond what we could see. Ancient texts spoke of hidden chambers, underground passages, and sacred spaces sealed away from the world above. Most archaeologists dismiss these as fantasy or wishful thinking. After all, decades of exploration, from Napoleon's expedition to modern robotic surveys, had mapped every accessible inch of the pyramid's interior. What more could there be? The answer, it turns out, was literally right beneath our feet. Muon detection technology works on a principle that sounds almost like science fiction. Cosmic rays constantly bombard our planet from deep space. When these high-energy particles hit Earth's atmosphere, they create muons, subatomic particles that can penetrate solid rock and stone with ease. But here's the crucial part. They travel at different speeds depending on what they pass through. Dense stone slows them down. Empty space lets them zip through virtually unimpeded. By placing sensitive detectors around and within the Great Pyramid, scientists can essentially create a 3-dimensional X-ray of the entire structure. They can see not just what's there, but what isn't there. Every void, every hollow space, every chamber or passage shows up as a distinct signature in the Muon data. This technology has been used before to study the Great Pyramid. In 2017, the Scan Pyramids project detected the famous Big Void above the Grand Gallery using similar techniques. But that discovery, remarkable as it was, focused primarily on spaces within the pyramid's masonry. What makes this new research revolutionary is where they pointed their detectors. Instead of looking up into the monument, they looked down, deep into the bedrock foundation. What they found defied every expectation. The first anomaly appeared almost immediately in the data, directly beneath the pyramid's center, extending downward from the known subterranean chamber. The scans revealed what appeared to be a vertical shaft. Not the rough, unfinished tunnel we might expect from an abandoned construction project, but a precisely carved passage with smooth walls and a consistent diameter. This shaft descended far deeper than anyone had imagined possible, disappearing beyond the range of the current scanning equipment. But that was just the beginning. As the team expanded their survey area, more anomalies began to emerge from the data. Horizontal passages branching off from the central shaft, chambers of various sizes scattered throughout the bedrock, corridors that seemed to follow geometric patterns, creating a network that extended well beyond the pyramid's base footprint. The most striking discovery was what the researchers are calling the mirror chamber. Located directly beneath the king's chamber, at a depth that corresponds almost exactly to the height of the chamber above ground, sits a void of nearly identical dimensions. It's as if the ancient builders created a perfect reflection of the pyramid's most sacred space, hidden in the darkness below. This discovery alone would be enough to revolutionize our understanding of the Great Pyramid. But the scans revealed something even more extraordinary. The underground network isn't isolated. Multiple passages appear to connect different areas of the complex, creating what can only be described as a subway system carved into solid rock. Some of these passages run perfectly straight for hundreds of meters. Others curve and wind in patterns that suggest they were designed to serve specific purposes we can't yet understand. The precision required to create such a network boggles the mind. We're not talking about crude tunnels hacked out with primitive tools. The Muon data suggests smooth walls, consistent dimensions, and architectural planning that rivals anything we see in the pyramid above. This level of sophistication forces us to completely reconsider what we know about ancient Egyptian capabilities. Think about the logistics involved. Every ton of rock removed from these underground spaces had to go somewhere. The ancient builders would have needed to move millions of cubic meters of stone, all while maintaining the structural integrity of the pyramid being constructed above. They would have needed lighting systems to work in the darkness, ventilation to provide breathable air, and engineering knowledge to prevent collapse. Yet somehow, they accomplished all of this without leaving any surface evidence of their work. No spoil heaps, no access ramps, no obvious entrances. The underground complex appears to have been sealed so completely that it vanished from human knowledge for millennia. But why? What possible purpose could justify such an enormous undertaking? The answer might lie in ancient Egyptian religious beliefs about the afterlife. The pyramid texts and other sacred writings describe the pharaoh's journey through the Duat, the underworld realm where souls face trials and judgments before achieving eternal life. This journey wasn't just metaphorical. The Egyptians believed in a very real physical underworld that existed beneath the surface of the earth. Could the underground complex beneath the Great Pyramid be a physical representation of the Duat? A place where the deceased pharaoh's spirit could navigate the challenges of the afterlife in an environment specifically designed for that purpose. The mirror chamber beneath the king's chamber would make perfect sense in this context. The pharaoh's mummy would rest in the chamber above while his spirit descended to its reflection below, beginning the eternal journey through the underworld. This interpretation gains support from the apparent layout of the underground network. The passages don't seem random or utilitarian. They follow patterns that might correspond to the pathways described in ancient funerary texts. The various chambers could represent different stages of the afterlife journey, each serving a specific ritual or symbolic purpose. Of course, there are other possibilities. Some researchers suggest the underground complex might have been a massive water management system, designed to channel and control the flow of groundwater beneath the pyramid. The ancient Egyptians were master hydraulic engineers, and we know that water played important roles in their religious ceremonies. An underground network of channels and reservoirs could have supplied water for ritual purposes, while also protecting the pyramid's foundation from moisture damage. Another theory proposes that the complex served as a secure storage facility for treasures, sacred objects, or important documents. The underground location would protect these items from tomb robbers, political upheaval, or natural disasters. Some researchers even speculate that the legendary Hall of Records, supposedly containing the accumulated wisdom of ancient Egypt, might be hidden somewhere within this network. But perhaps the most intriguing possibility is that the underground complex represents something we haven't considered before. something that challenges our basic assumptions about what the Great Pyramid was meant to be and do. Recent research has suggested that the Great Pyramid might have functioned as more than just a tomb. Some scientists propose it was designed as a type of ancient machine, using acoustic resonance, electromagnetic fields, or other physical principles we're only beginning to understand. If this is true, then the underground network might be an integral part of this system, providing the foundation and infrastructure necessary for the pyramid to function as intended. The Muon scans hint at features that could support this interpretation. Some of the underground chambers appear to be positioned at specific geometric relationships to the pyramid above. The passages seem to follow alignments that correspond to astronomical phenomena. The overall layout suggests a level of planning and purpose that goes far beyond simple burial preparations. Whatever the truth, one thing is clear. The Great Pyramid is far more complex and sophisticated than we ever realized. The monument we thought we understood turns out to be only the visible portion of a much larger and more ambitious project. The real pyramid, the complete pyramid, extends deep into the earth, creating a three-dimensional masterpiece that combines architecture, engineering, astronomy, and religious symbolism in ways we're only beginning to appreciate. The implications of this discovery extend far beyond Egyptology. If the ancient Egyptians possessed the knowledge and capability to create such an underground complex, what else might they have accomplished that we've overlooked or dismissed? How many other ancient sites around the world might be hiding similar secrets beneath their foundations? These questions become even more pressing when we consider the technology used to make this discovery. Muon detection is still a relatively new archaeological tool, and it's only been applied to a handful of sites worldwide. As the technology becomes more widespread and sophisticated, we might find that underground complexes are far more common than we currently realize. The Great Pyramid's hidden labyrinth also raises practical questions about exploration and preservation. How do we investigate these underground spaces without damaging them or compromising the structural integrity of the pyramid above? The chambers and passages have remained sealed for millennia, preserving whatever lies within them in pristine condition. Any attempt to access them physically would inevitably introduce contamination and risk destruction of priceless archaeological evidence. For now, the underground complex remains tantalizingly out of reach, visible only through the ghostly images created by Muon detection. But as scanning technology continues to improve, we may be able to create increasingly detailed maps of what lies beneath. Eventually, we might even develop methods to explore these spaces remotely, using robotic probes or other non-invasive techniques. The more we study these Muon scans, the more questions emerge from the shadows of ancient stone. Because what we're looking at isn't just a collection of random voids and passages. There's something deliberate here, something that suggests the ancient builders weren't just thinking about their pyramid in isolation. They were creating something that connected to a much larger vision of what this monument was supposed to achieve. Consider the timing of when this underground network would have been constructed. The logistics alone are staggering. These passages and chambers would have needed to be carved before or during the pyramid's construction, not after. You can't excavate a massive underground complex beneath millions of tons of precisely placed limestone blocks. This means the entire project, both above and below ground, was planned as a unified whole from the very beginning. But here's what makes this even more remarkable. The ancient Egyptians accomplished this feat without any of the modern tools we consider essential for such work. No electric lighting to illuminate the depths, no mechanical ventilation systems to provide fresh air, no modern surveying equipment to ensure precise alignment and measurement, no power tools to speed the excavation process. Yet somehow, they created passages that run perfectly straight for hundreds of meters through solid bedrock. They carved chambers with walls so smooth and regular that they appear almost machine-made in the Muon data. They engineered a network that maintains structural integrity despite the enormous weight pressing down from above. This level of precision and planning suggests a degree of organizational capability that historians are only beginning to appreciate. We're not talking about a simple construction project managed by a single architect or even a small team of experts. This would have required coordination between hundreds, possibly thousands, of skilled workers, each performing specialized tasks that had to integrate seamlessly with the work of others. The underground excavation teams would have needed to work in perfect synchronization with the surface construction crews. The removal of millions of tons of bedrock would have generated enormous amounts of debris that somehow had to be transported away from the site without leaving any archaeological trace. The timing of each phase of construction would have been critical to maintain the structural stability of both the underground complex and the rising pyramid above. And through it all, they maintained absolute secrecy. No contemporary records describe this underground construction. No ancient texts mention the hidden passages and chambers. No tomb paintings depict workers laboring in the depths beneath the pyramid. It's as if the entire underground project was classified at the highest levels of ancient Egyptian society, known only to those who absolutely needed to know. This deliberate concealment raises profound questions about the true purpose of what lies beneath. If the underground complex was simply an extension of the burial arrangements for Pharaoh Khufu, why hide it so completely? Royal tombs were typically celebrated and documented, not erased from memory. The pharaoh's journey to the afterlife was a public concern, involving elaborate rituals and ceremonies that the entire kingdom participated in. But what if the underground network served a different purpose entirely? What if it was designed for something that required absolute secrecy, something that couldn't be shared with the general population, or even with most of the royal court? The Muon scans provide tantalizing clues about what this purpose might have been. Some of the detected chambers appear to be positioned at locations that correspond to specific astronomical alignments. The passages seem to follow orientations that match the cardinal directions with extraordinary precision. The overall layout suggests that whoever designed this network understood principles of geometry and engineering that we're only rediscovering today. One particularly intriguing aspect of the underground complex is its relationship to water. The Muon data suggests that some of the passages might have been designed to channel or contain flowing water. This makes sense from an engineering perspective, as groundwater management would have been crucial for the long-term stability of both the pyramid and the underground spaces. But water held a deeper significance in ancient Egyptian religious thought. It wasn't just a practical necessity, it was a fundamental element of creation and rebirth. The annual flooding of the Nile brought life to the desert. Sacred pools in temples provided purification for priests and worshippers. The primordial waters of Nun were believed to be the source from which all existence emerged. Could the underground passages have been designed to channel sacred waters through ritual spaces hidden beneath the pyramid? The ancient Egyptians were master hydraulic engineers, capable of creating sophisticated systems for moving and controlling water flow. An underground network of channels and chambers could have created a hidden temple complex where water-based ceremonies took place away from public view. This interpretation gained support from recent discoveries at other Egyptian sites. Archaeological excavations have revealed that many temples and royal complexes included elaborate underground water systems that served both practical and religious functions. Sacred pools, ritual baths, and ceremonial channels were common features of important religious sites throughout ancient Egypt. If the Great Pyramid's underground complex includes similar water features, it would represent the most sophisticated example of ancient hydraulic engineering ever discovered. The precision required to create channels that would function properly at such depths, while maintaining the structural integrity of the pyramid above, would demonstrate capabilities that rival modern engineering techniques. But water management might be only one aspect of a much more complex system. The Muon scans suggest that the underground network was designed with multiple functions in mind. Some areas appear optimized for water flow, while others seem intended for different purposes entirely. The large chambers detected deep beneath the pyramid could have served as gathering spaces for secret ceremonies or initiations. Ancient Egyptian religion included mystery traditions that were revealed only to select initiates who had proven their worthiness through elaborate trials and preparations. These esoteric teachings were considered so sacred and powerful that they were never written down or discussed openly. Could the underground complex have been designed as a physical setting for these mystery initiations? The journey through dark passages and hidden chambers would provide a powerful metaphor for the spiritual transformation that initiates were expected to undergo. The mirror chamber beneath the king's chamber could have served as the ultimate sanctuary where the most profound secrets were revealed. This possibility becomes even more intriguing when we consider the acoustic properties of underground spaces. Sound behaves differently in enclosed chambers, creating resonances and echoes that can produce profound psychological effects. Many ancient sites around the world seem to have been designed with acoustic considerations in mind, using sound as a tool for inducing altered states of consciousness during religious ceremonies. The underground chambers beneath the Great Pyramid might have been specifically engineered to produce particular acoustic effects. The smooth walls suggested by the Muon data would create ideal conditions for sound reflection and amplification. Chanting, music, or spoken words could have been enhanced and transformed by the underground architecture, creating an otherworldly atmosphere that reinforced the sacred nature of whatever ceremonies took place there. Recent research has also revealed that the Great Pyramid exhibits unusual electromagnetic properties. The monument seems to concentrate and focus electromagnetic energy in ways that scientists are still trying to understand. Some researchers have proposed that these effects were intentional, that the pyramid was designed to function as a type of ancient technological device. If this is true, then the underground network might be an integral part of this system. The passages and chambers could serve as conduits for electromagnetic energy, channeling and directing forces in ways that we're only beginning to comprehend. The precise positioning of the underground features relative to the pyramid above suggests that their designers understood principles of physics that we've only recently rediscovered. This technological interpretation of the Great Pyramid remains highly controversial within mainstream archaeology. Most scholars prefer explanations that focus on religious and symbolic functions rather than speculating about ancient high technology. But the sophistication revealed by the Muon scans makes it increasingly difficult to dismiss the possibility that the pyramid's builders possessed knowledge and capabilities that we've seriously underestimated. Whatever the truth about the underground complex's original purpose, its discovery has already begun to transform our understanding of ancient Egyptian civilization. The level of planning, engineering, and construction capability required to create such a network forces us to acknowledge that we've been thinking too small about what these ancient people could accomplish. The implications extend far beyond the Great Pyramid itself. If the Egyptians could create such an elaborate underground complex beneath their most important monument, what might lie hidden beneath other pyramids, temples, and royal sites throughout the Nile Valley? How many other secrets remain buried in the sands, waiting for advanced technology to reveal their existence? The Muon detection techniques that uncovered this labyrinth are still being refined and improved. As the technology becomes more sensitive and precise, we may be able to create even more detailed maps of what lies beneath Giza. We might discover additional chambers, passages, or features that aren't visible in the current scans. More importantly, similar surveys could be conducted at other archaeological sites around the world. Many ancient monuments and complexes might be hiding underground components that we've never suspected. The Great Pyramid's hidden labyrinth might be just the first of many such discoveries that will revolutionize our understanding of ancient civilizations. But for now, the underground network remains tantalizingly out of reach, visible only in the ethereal images created by cosmic particles streaming down from space. Each muon that passes through those hidden chambers carries with it a ghost of information about spaces that have remained sealed in darkness for over 4,000 years. Somewhere in that labyrinth, Carved into living rock beneath one of humanity's greatest monuments, lies evidence that could rewrite everything we thought we knew about the ancient world. The question is no longer whether these chambers exist. The question is what we'll find when we finally discover a way to reach them. The technology that revealed this underground labyrinth represents one of the most significant advances in archaeological investigation since the invention of ground-penetrating radar. But to truly understand what makes this discovery so extraordinary, we need to grasp just how revolutionary muon detection has become in unlocking secrets that have remained hidden for millennia. Unlike traditional archaeological methods that require physical excavation or surface-based scanning techniques with limited depth penetration, muon tomography can peer deep into solid matter without disturbing a single grain of sand. The cosmic rays that constantly bombard our planet create these subatomic particles high in the atmosphere, and they rain down on Earth continuously, day and night, regardless of weather conditions. What makes muons so valuable for archaeology is their unique behavior when passing through different materials. When a muon encounters dense stone or solid rock, it slows down and can be absorbed or deflected. But when it passes through empty space or less dense materials, it maintains its speed and direction with minimal interference. By placing sophisticated detectors at strategic locations around a structure, scientists can map these variations in muon behavior to create detailed three-dimensional images of what lies hidden inside. The team studying the Great Pyramid didn't just place their equipment randomly around the monument. They spent months calculating optimal detector positions based on the known internal structure of the pyramid and the suspected locations of potential voids. Each detector had to be precisely calibrated and synchronized with the others to ensure that the data they collected could be accurately combined into coherent images. The process requires enormous patience. Unlike taking a photograph that captures an image instantly, muon detection requires collecting data over extended periods to build up sufficient particle counts for reliable analysis. The detectors at Giza operated continuously for over 18 months, recording millions of individual muon interactions before the research team had enough data to begin creating their underground maps. But even with all this data, interpreting the results requires sophisticated computer modeling and analysis. The raw muon counts don't immediately reveal chamber shapes or passage layouts. Instead, they provide density variations that must be processed through complex algorithms to transform particle statistics into architectural blueprints. This is where the true breakthrough occurred. When the research team's computers finished processing the accumulated muon data, the images that emerged from their analysis were unlike anything anyone had expected to find. Instead of the simple, relatively sparse underground structure that most experts predicted, the scans revealed a complex network that rivals the visible pyramid in its scope and sophistication. The central vertical shaft that descends from the known subterranean chamber turns out to be just one element of a much larger system. Branching off from this main shaft at regular intervals are horizontal passages that extend in all four cardinal directions. These aren't crude tunnels hacked through rock, but precisely engineered corridors with consistent dimensions and smooth walls. At the termination points of several major passages, the muon scans detect large rectangular chambers that appear to have been carved with mathematical precision. The largest of these spaces measures approximately 40 meters in length, 25 meters in width, and 8 meters in height. To put this in perspective, this single underground chamber has more floor space than most modern houses and could easily accommodate several hundred people. But what truly sets these underground spaces apart is their relationship to the pyramid's surface geometry. The passages don't run randomly through the bedrock. Instead, they follow alignments that correspond precisely to the pyramid's base edges and internal features. The major corridors extend along north-south and east-west axes that match the pyramid's cardinal orientation with an accuracy that exceeds the precision of many modern construction projects. This geometric correspondence suggests that the underground network wasn't an afterthought or a separate construction project. It was integrated into the pyramid's design from the very beginning, with the surface monument and the subterranean complex planned as complementary parts of a unified whole. The implications of this integrated design are staggering. It means that when the ancient Egyptian architects were planning the Great Pyramid, they weren't just thinking about a tomb or monument that would rise above the desert. They were envisioning a three-dimensional complex that would extend both upward toward the sky and downward into the earth, creating a structure that exists simultaneously in multiple realms. This concept aligns perfectly with ancient Egyptian religious beliefs about the nature of existence and the afterlife. The Egyptians saw the world as divided into distinct but interconnected realms. The sky above, where the gods resided, the earth's surface, where the living dwelt, and the underworld below, where the dead journeyed toward rebirth and eternal life. A monument that physically spans all three of these realms would represent the ultimate expression of this cosmological understanding. The pyramid's peak reaches toward the heavens, its base occupies the earthly realm, and its hidden foundations extend into the underworld domain. The deceased pharaoh's spirit could navigate between all three levels of existence without ever leaving the sacred space of the monument. This interpretation gains additional support from the specific locations of the underground chambers detected by the Muon scans. Several of the largest spaces appear to be positioned directly beneath key features of the pyramid's internal structure. The mirror chamber beneath the king's chamber is just one example of this precise vertical alignment. The Muon data also reveals what appears to be a second large chamber positioned beneath the queen's chamber, though this space seems to have different proportions and possibly a different function than its surface counterpart. Additional chambers have been detected beneath the Grand Gallery and at locations that correspond to other significant features of the pyramid's internal architecture. These vertical alignments suggest that the underground complex wasn't just inspired by the surface structure's layout. It was designed to create direct spiritual or symbolic connections between corresponding spaces above and below ground. The pharaoh's mummy, resting in the king's chamber, would be directly connected to ritual spaces in the underworld realm below. But the underground network includes features that have no obvious counterparts in the visible pyramid. Long straight passages extend far beyond the pyramid's base footprint, reaching distances that would place their endpoints well outside the monument's perimeter. Some of these corridors appear to terminate in additional chamber complexes that are completely independent of the surface structure. The purpose of these outlying spaces remains completely mysterious. They could represent storage areas for grave goods, treasures, or sacred objects that were too valuable or dangerous to keep within the main pyramid complex. They might be ritual chambers designed for specific ceremonies that required isolation from the primary burial spaces, or they could serve functions that we haven't even considered yet. One particularly intriguing possibility is that these distant chambers were designed as waypoints or rest stops along underground processional routes. Ancient Egyptian funeral ceremonies often involved elaborate processions that moved the deceased pharaoh's mummy and accompanying grave goods along carefully planned paths that held religious significance. If such processions included underground components, the outlying chambers could have served as staging areas where different phases of the burial ritual were performed. The pharaoh's funeral cortege might have descended into the subterranean network at one location, proceeded through the underground passages while performing specific ceremonies at designated chambers, and finally emerged at the main pyramid for the concluding burial rites. This scenario would explain why the underground passages extend so far from the pyramid itself, and why they include multiple chamber complexes rather than a single centralized space. Each chamber would serve a specific ritual function within the overall funeral ceremony, creating an underground temple complex that was integral to the pharaoh's transition from earthly ruler to divine being. The Muon scans also hint at features that could support this processional interpretation. Some of the detected passages appear to include regular alcoves or recesses that might have held statues, ritual objects, or offerings. Other corridors seem to widen into antechamber spaces before connecting to the main underground rooms. These architectural details suggest that the passages weren't just utilitarian corridors designed for simple transportation. They were ceremonial spaces in their own right, carefully designed to create appropriate settings for the religious activities that would take place within them. The acoustic properties of these underground spaces would have been particularly important for ceremonial functions. Sound travels differently in enclosed stone chambers than it does in open air, creating resonances and echoes that can produce profound psychological effects on listeners. Chanting, music, or spoken prayers would be transformed by the underground architecture, creating an otherworldly atmosphere that reinforced the sacred nature of the ceremonies. Recent research at other ancient sites has revealed that many cultures understood and deliberately exploited these acoustic phenomena. The Oracle Chamber at Delphi, the Hypogeum of Malta, and various Native American ceremonial caves all demonstrate sophisticated understanding of how underground spaces can be designed to enhance ritual experiences through carefully controlled sound environments. The Great Pyramid's underground chambers might represent the most advanced example of such acoustic engineering in the ancient world. The smooth walls and precise dimensions detected by the Muon scans would create ideal conditions for sound manipulation. Specific frequencies could be enhanced or suppressed, creating audio effects that would seem magical to participants in underground ceremonies. But beyond their potential ceremonial functions, the underground passages raise fundamental questions about ancient Egyptian engineering capabilities. The logistics of creating such an extensive network would have been extraordinarily complex, requiring coordination between multiple specialized teams working in challenging conditions. The excavation itself would have generated millions of cubic meters of debris that somehow had to be removed from the site without leaving any surface evidence. The ancient builders would have needed sophisticated systems for moving this material through narrow passages and up vertical shafts, all while maintaining the structural integrity of the growing pyramid above. They would also have required advanced surveying techniques to ensure that passages carved from different access points would meet precisely at their intended intersections. Working in complete darkness, using only oil lamps or torches for illumination, the construction teams would have needed to maintain exact alignments across distances of hundreds of meters through solid rock. The precision achieved in this underground construction actually exceeds what we see in many modern tunneling projects. Contemporary engineers, with all their advanced equipment and measurement technology, often struggle to maintain the level of accuracy that the ancient Egyptians somehow achieved using Bronze Age tools and techniques. This remarkable precision becomes even more impressive when we consider the geological challenges the ancient builders would have faced. The bedrock beneath the Geyser Plateau isn't uniformly consistent. It includes layers of different limestone types, some harder and some softer, along with occasional pockets of sand, clay, or other materials that would have required different excavation approaches. Yet the Muon scans show passages that maintain consistent dimensions and alignments, regardless of these geological variations. The ancient engineers somehow adapted their techniques to work with whatever rock conditions they encountered, while never deviating from their planned routes or specifications. This level of geological knowledge and engineering adaptability suggests that the pyramid builders possess scientific understanding that we've seriously underestimated. They weren't just skilled craftsmen following traditional construction methods. They were sophisticated engineers capable of solving complex technical problems that would challenge modern professionals. The question of how they acquired this knowledge becomes even more intriguing when we consider that the Great Pyramid was built relatively early in Egyptian history. The Old Kingdom period, when the pyramid was constructed, was supposedly a time when Egyptian civilization was still developing its technological capabilities. Yet the underground complex demonstrates engineering skills that seem to have appeared fully formed, without obvious precedents or developmental stages. This technological sophistication extends beyond just the excavation and construction techniques. The underground network would have required ventilation systems to provide breathable air for workers and possibly for later ceremonial use. The Muon scans hint at features that might represent air shafts or ventilation channels, though their exact configuration remains unclear from the current data. Ancient Egyptian engineers were known for their skill in creating natural ventilation systems that used temperature and pressure differentials to move air through enclosed spaces. The underground complex might include similar systems, possibly integrated with the known air shafts of the pyramid above, to create a unified atmospheric management system for the entire monument. Water management would have been another critical consideration. The underground passages would need drainage systems to prevent flooding during rare but devastating desert storms. They would also need protection against groundwater infiltration that could undermine the structural stability of both the underground spaces and the pyramid above. Some of the features detected in the Muon scans might represent elements of such water management systems. Linear features that don't quite match the pattern of passages or chambers could be drainage channels or waterproof barriers designed to control moisture flow through the underground complex. But water might have served purposes beyond just practical engineering considerations. As we've discussed, water held profound religious significance in ancient Egyptian culture. Sacred pools, ritual baths, and ceremonial channels were common features of important temples and religious sites throughout the Nile Valley. The underground complex beneath the Great Pyramid might have included similar water features, creating a hidden temple environment where purification ceremonies and other water-based rituals could be performed away from public view. The sound of flowing water would have enhanced the otherworldly atmosphere of the underground spaces, while the spiritual significance of sacred water would have reinforced the religious importance of whatever ceremonies took place there. These multiple layers of function, engineering, and symbolism create a picture of the Great Pyramid that is far more complex and sophisticated than anything we previously imagined. The monument we thought we understood turns out to be only the visible portion of an integrated system that extends deep into the earth, creating a three-dimensional masterpiece that combines architecture, engineering, astronomy, hydraulics, acoustics, and religious symbolism in ways that we're only beginning to appreciate. The discovery of this underground labyrinth forces us to completely reconsider our assumptions about ancient Egyptian capabilities and ambitions. These weren't primitive people struggling with basic construction challenges. They were sophisticated engineers and architects capable of planning and executing projects that rival anything we might attempt today. More importantly, they were visionaries who thought on a scale that transcends our modern understanding of what ancient monuments were supposed to accomplish. The Great Pyramid wasn't just a tomb or even just a religious symbol. It was something far more ambitious. A complete artificial environment designed to serve functions that we're still trying to comprehend. And somewhere in that hidden labyrinth, carved into living rock, beneath humanity's most enigmatic monument, lies evidence that will revolutionize our understanding of what ancient civilizations could achieve when they set their minds to truly monumental goals. The most haunting aspect of this underground labyrinth isn't what we can see in the Muon scans, but what we can't. Because scattered throughout the data are anomalies that don't fit any conventional explanation. Features that appear and disappear in ways that suggest the underground network might be even more complex than we initially realized. Some of these anomalies manifest as what researchers are calling density shadows, areas where the Muon readings suggest something is there, but the signatures don't match typical stone or empty space. These shadows appear at regular intervals throughout the underground passages, almost like markers or waypoints placed at specific distances along the corridors. What could create such unusual readings? One possibility is that these locations contain objects or materials with different atomic densities than the surrounding limestone. Metal artifacts, for instance, would create distinct Muon signatures that could appear as density shadows in the scans. But if that's the case, we're talking about metallic objects large enough to be detected through hundreds of meters of solid rock. The implications are staggering. If the ancient Egyptians placed large metal objects at regular intervals throughout their underground network, what purpose could they have served? Were they structural reinforcements to prevent collapse? Ritual objects marking sacred locations? Or something else entirely that we haven't considered? Another category of anomalies shows up as what the research team calls flux variations, areas where Muon readings fluctuate in patterns that don't correspond to static architectural features. These variations suggest the presence of spaces or materials that somehow affect Muon behavior in ways that solid stone chambers don't. The most intriguing of these flux variations appears to be located at the deepest accessible point of the central shaft. Here, the Muon readings create a signature unlike anything else detected in the underground complex. The data suggests a large void, but one filled with something that isn't quite empty space and isn't quite solid matter. Could this deepest chamber contain water? Ancient Egyptian engineering texts describe the use of underground pools and channels for both practical and religious purposes. A water-filled chamber at the bottom of the central shaft would explain the unusual Muon readings while also fitting perfectly with Egyptian beliefs about the primordial waters from which all life emerged. But water alone might not account for all the anomalous readings from this deep chamber. The flux patterns suggest something more complex, possibly a combination of water, suspended materials, and architectural features that create a unique environment, unlike anything else in the underground network. This deepest chamber might represent the ultimate destination of the entire underground system. In Egyptian mythology, the journey through the underworld concluded at the Hall of Two Truths, where the deceased's heart was weighed against the feather of Ma'at to determine their worthiness for eternal life. Could the mysterious chamber at the bottom of the central shaft be a physical representation of this final judgment hall? The religious significance of such a chamber would be immense. It would represent the point where the physical world connects to the spiritual realm, where earthly existence transitions to eternal life. The unusual Muon readings might reflect the presence of materials or configurations specifically chosen to create an environment suitable for this ultimate spiritual transformation. But the anomalies aren't limited to the deepest parts of the underground network. Strange readings appear throughout the system, suggesting that the entire complex might contain surprises that we haven't yet learned to interpret properly. Some passages show internal structures that don't match typical corridor architecture. Instead of simple tunnels with uniform cross-sections, certain sections appear to contain complex internal features, possibly alcoves, chambers, or installations that served specific functions within the overall system. These internal features might represent the ancient equivalent of modern mechanical systems. Just as contemporary buildings include spaces for electrical wiring, plumbing, and ventilation equipment, the underground passages might contain installations for lighting, air circulation, or other environmental controls that made the spaces habitable and functional. The lighting question is particularly intriguing. How did the ancient Egyptians illuminate these vast underground spaces during construction and later use? Oil lamps and torches would have provided some light, but they would also have consumed oxygen and produced smoke, serious problems in enclosed underground environments. Recent research has suggested that ancient Egyptians might have used polished metal mirrors to redirect sunlight into interior spaces of pyramids and temples. Could similar mirror systems have been used to illuminate the underground passages? The density shadows detected in the Muon scans might represent the remains of such mirror installations, corroded and collapsed after millennia of abandonment. Alternatively, the ancient Egyptians might have developed other lighting technologies that we haven't discovered or understood. Some fringe researchers have proposed that certain ancient cultures possess knowledge of electrical or chemical lighting systems that have been lost to history. While such claims remain highly speculative, the sophisticated engineering evident in the underground complex forces us to reconsider what technological capabilities these ancient people might have possessed. The ventilation challenge would have been equally critical. Fresh air circulation would have been essential not just for construction workers, but for anyone using the underground spaces for ceremonial or other purposes. The Muon scans hint at features that might represent air shafts or ventilation channels, but their exact configuration and operation remain mysterious. Ancient Egyptian architects were masters of natural ventilation design, using temperature differentials and air pressure variations to create circulation systems that required no mechanical power. The underground complex might include similar systems, possibly integrated with the known air shafts of the pyramid above, to create a unified atmospheric management system for the entire monument. But some of the features detected in the scans suggest ventilation systems more sophisticated than simple passive air circulation. Certain passages appear to include internal structures that might represent mechanical elements, possibly moving parts or adjustable components that could be used to control airflow through different sections of the underground network. The idea of mechanical systems in ancient Egyptian construction isn't as far-fetched as it might initially seem. Archaeological evidence has revealed that the Egyptians used sophisticated mechanical devices for moving heavy stones, operating temple mechanisms, and controlling water flow in irrigation systems. Applying similar mechanical principles to underground ventilation would represent a logical extension of their existing technological capabilities. These mechanical elements might also explain some of the flux variations detected in the Muon scans. Moving parts, even if they're no longer functional after millennia of abandonment, would create different density patterns than static stone architecture. Corroded metal components, collapsed wooden mechanisms, or accumulated debris from failed systems could all contribute to the anomalous readings that appear throughout the underground complex. The question of preservation becomes critical when considering what might remain intact within these sealed spaces. Unlike surface monuments that have been exposed to weathering, looting, and human interference for thousands of years, the underground chambers have remained completely isolated from external influences. This isolation means that whatever was placed in these chambers during their original construction might still be there, preserved in conditions that haven't changed significantly since the pyramid was completed. Organic materials that would have decayed long ago in surface environments might survive intact in the stable underground atmosphere. The possibilities are extraordinary. We might find wooden furniture, textile decorations, papyrus scrolls, or other perishable artifacts that could provide unprecedented insights into Old Kingdom Egyptian culture and beliefs. More importantly, we might discover materials that explain the true purpose and function of the underground complex. But preservation cuts both ways. While the sealed environment might protect ancient materials from decay, it also means that any attempt to access these spaces would inevitably introduce contamination and disturbance. Modern air, moisture, bacteria, and human presence would begin altering conditions that have remained stable for over 4,000 years. This creates a profound ethical and practical dilemma for archaeologists and researchers. How do we investigate these spaces without destroying the very evidence we're trying to preserve? Traditional excavation methods, which involve physical access and direct manipulation of archaeological materials, would be inappropriate for such pristine and potentially fragile environments. The answer might lie in developing new technologies that can explore and document the underground spaces without requiring human presence or physical disturbance. Advanced robotic systems, equipped with sophisticated sensors and imaging equipment, might be able to navigate the passages and chambers while leaving them essentially undisturbed. Such robotic exploration would represent a new frontier in archaeological investigation. Instead of archaeologists carefully excavating artifacts by hand, remote sensors would capture detailed information about objects and features that would never be physically touched or moved. Digital preservation would replace physical collection, creating virtual museums of spaces that remain forever sealed. The technological challenges of such an approach would be immense. Robotic systems would need to operate in complete darkness, navigate through narrow passages and around potential obstacles, and function reliably in environments that haven't been disturbed for millennia. They would need power systems capable of extended operation without external connections, communication systems that can transmit data through hundreds of meters of solid rock, and sensors sophisticated enough to capture information equivalent to traditional archaeological documentation methods. But the potential rewards justify the technological investment. The underground chambers beneath the Great Pyramid might contain the most complete and undisturbed collection of Old Kingdom Egyptian artifacts ever discovered. More importantly, they might hold answers to questions about Egyptian capabilities, beliefs, and intentions that have puzzled researchers for generations. The religious significance of these spaces adds another layer of complexity to any exploration efforts. The underground complex wasn't just a construction project. It was a sacred environment designed to serve specific spiritual functions that were central to ancient Egyptian beliefs about death and the afterlife. Disturbing these spaces, even for scientific purposes, raises questions about respect for ancient religious beliefs and practices. While the original users of these chambers have been gone for thousands of years, many people today still consider ancient Egyptian religious sites to be sacred spaces that deserve protection from unnecessary interference. This consideration becomes particularly important when we remember that the underground complex was deliberately sealed and hidden. The ancient Egyptians who created these spaces made a conscious decision to close them off from human access. Perhaps they intended for these chambers to remain undisturbed forever, serving their religious functions without interference from the living world above. Balancing scientific curiosity with respect for ancient intentions creates a delicate ethical framework for any future investigation of the underground labyrinth. We want to understand what lies beneath the Great Pyramid, but we also need to consider whether our desire for knowledge justifies violating the deliberate concealment that the ancient builders worked so hard to achieve. These ethical questions become even more complex when we consider the potential global significance of what might be hidden in the underground chambers. If these spaces contain evidence that revolutionizes our understanding of ancient Egyptian capabilities or human history more broadly, do we have an obligation to humanity to investigate them regardless of other considerations? The answer isn't clear, and it might vary depending on what future research reveals about the contents and purpose of the underground complex. But what is clear is that any decision about how to proceed must be made carefully, with full consideration of all the scientific, ethical, and cultural factors involved. For now, the underground labyrinth remains tantalizingly out of reach, visible only through the ghostly images created by cosmic particles streaming down from space. Each muon that passes through those hidden chambers carries with it a fragment of information about spaces that have remained sealed in darkness for over 4,000 years. But as our technology continues to advance and our understanding of the underground complex grows more sophisticated, the day may come when we finally find a way to unlock the secrets that lie buried beneath humanity's most enigmatic monument. When that day arrives, we might discover that everything we thought we knew about the ancient world was just the beginning of a much larger and more extraordinary story. The Muon scans have already begun to rewrite the story of the Great Pyramid, transforming it from a simple tomb into something far more complex and mysterious. But the underground labyrinth might be just the first of many such discoveries that await us as we develop new ways of seeing into the hidden depths of our ancient past. Somewhere in that network of passages and chambers, carved into living rock beneath one of humanity's greatest achievements, lies evidence that could change everything. The only question is whether we'll have the wisdom to approach it with the respect and care that such a momentous discovery deserves. Because ultimately, the underground labyrinth beneath the Great Pyramid isn't just about ancient Egypt or even about archaeology. It's about the fundamental human drive to understand our past, to push the boundaries of what we think is possible, and to discover truths that have been waiting in darkness for us to develop the technology and wisdom necessary to uncover them. And that journey of discovery is far from over. The questions surrounding this underground network become even more compelling when we examine what the Muon scans reveal about the construction sequence. Because what we're seeing isn't just evidence of remarkable engineering capability. We're looking at proof of planning and coordination that operated on a scale unlike anything else in the ancient world. Think about the logistics for a moment. The ancient Egyptians would have needed to excavate this entire underground complex before completing the pyramid above. You can't carve passages and chambers through bedrock once millions of tons of precisely placed limestone blocks are pressing down from overhead. This means the entire project, both the visible monument and the hidden labyrinth beneath, was conceived and executed as a single, unified construction effort. But here's what makes this even more extraordinary. The pyramid itself took an estimated 20 to 30 years to complete, employing thousands of workers organized into specialized teams. Now imagine coordinating that massive surface construction project while simultaneously managing an equally complex underground excavation that had to remain completely hidden from view. The underground work crews would have operated in shifts around the clock, working by lamplight in conditions that modern occupational safety standards would never permit. They would have needed sophisticated systems for removing debris, maintaining air quality, and ensuring structural stability as both the surface and subsurface construction progressed. Yet somehow, they accomplished all of this without leaving any archaeological evidence of their underground activities. No spoil heaps from the excavated bedrock, no surface installations for moving materials or personnel into the depths, no obvious access points that would reveal the existence of the hidden network to later generations. This level of operational security suggests that knowledge of the underground complex was restricted to a very small group of individuals at the highest levels of ancient Egyptian society. Perhaps only the pharaoh himself and his most trusted architects and priests were aware of the full scope of what was being created beneath the pyramid. The religious implications of such secrecy are profound. In ancient Egyptian belief, the pharaoh's successful transition to the afterlife wasn't just a personal matter. It was essential for the continued prosperity and stability of the entire kingdom. The pharaoh's divine nature meant that his eternal well-being directly affected the welfare of all his subjects. If the underground complex was designed to ensure the pharaoh's safe passage through the underworld, then protecting its secrecy would have been considered vital to national security. Knowledge of its existence, layout, or function couldn't be allowed to fall into the wrong hands, where it might be used to disrupt or interfere with the pharaoh's eternal journey. This interpretation helps explain why the underground network was so completely erased from historical memory. It wasn't just hidden during construction, it was deliberately forgotten, with all records of its existence systematically eliminated to prevent future interference with its sacred function. But the Muon scans suggest that the underground complex served functions beyond just royal burial preparations. Some of the detected chambers and passages appear to have been designed for ongoing use rather than sealed storage. These spaces might have remained accessible to select priests or initiates who continued to perform ceremonies within the underground network long after the pharaoh's burial. The possibility of continued use raises fascinating questions about secret traditions within ancient Egyptian religion. We know that Egyptian temple complexes often included mystery schools where advanced spiritual teachings were transmitted to carefully chosen initiates. These esoteric traditions were never written down or discussed publicly, being passed instead through direct instruction and ritual experience. Could the underground chambers beneath the Great Pyramid have served as the ultimate mystery school, where the most profound secrets of Egyptian spirituality were taught and practiced? The journey through dark passages to reach hidden chambers would provide a powerful metaphor for the spiritual transformation that initiates were expected to undergo. The acoustic properties of these underground spaces would have been perfect for such purposes. Recent research has shown that many ancient sites were designed with sophisticated understanding of how sound behaves in enclosed spaces. Specific frequencies can be enhanced or suppressed, creating audio effects that profoundly impact human consciousness and emotional states. Chanting, music, or spoken words would be transformed by the underground architecture, creating otherworldly atmospheres that reinforce the sacred nature of whatever ceremonies took place there. The smooth stone walls, suggested by the Muon data, would create ideal conditions for these acoustic manipulations. But sound might not have been the only sensory element carefully controlled within the underground complex. The complete darkness of spaces hundreds of meters beneath the surface would create conditions of sensory deprivation that can induce altered states of consciousness, even without other interventions. Ancient mystery traditions around the world often incorporated periods of darkness and isolation as methods for achieving spiritual insights. The underground chambers would provide natural settings for such practices, creating environments where normal sensory input was eliminated, and consciousness could be directed inward toward mystical experiences. The psychological impact of descending through narrow passages deep into the earth would have been enormous. Initiates would literally be leaving the world of light and life behind, journeying into a realm of darkness and stone that mirrored the underworld described in Egyptian religious texts. This physical journey would serve as preparation for the spiritual journey that the initiate was expected to undertake. By the time they reached the deepest chambers of the underground complex, they would be in a psychological state primed for profound transformation. The specific layout of the passages and chambers detected in the Muon scans seems designed to enhance these psychological effects. The central shaft descends gradually rather than dropping straight down, creating a sense of slow transition from the surface world to the underground realm. The horizontal passages branch off at regular intervals, creating choices and decision points that would add complexity to the underground journey. Some passages appear to lead to dead ends or small chambers that might have served as meditation spaces or areas for individual contemplation. Others connect to larger chambers that could accommodate group ceremonies or teachings. The overall design suggests a carefully planned environment where different types of spiritual activities could take place simultaneously. This multifunctional aspect of the underground complex aligns with what we know about Egyptian temple design. Major religious sites typically included spaces for public worship, private meditation, ritual purification, sacred storage, and priestly instruction. The underground network might represent the most sophisticated example of such integrated religious architecture ever created. But the religious functions of the underground complex might have been only one aspect of a much larger system. The precision of the construction, the integration with the pyramid's geometry, and the sophisticated engineering solutions evident throughout the network suggest purposes that go beyond ceremonial or symbolic functions. Recent research has revealed that the Great Pyramid exhibits unusual physical properties that scientists are still trying to understand. The monument seems to interact with electromagnetic fields in ways that suggest its builders possessed knowledge of physics principles that we've only recently rediscovered. Some researchers have proposed that the pyramid was designed to function as a type of ancient machine, using acoustic resonance, electromagnetic focusing, or other physical phenomena to achieve purposes that remain mysterious. If this interpretation is correct, then the underground network might be an integral part of this technological system. The passages and chambers could serve as conduits for electromagnetic energy, resonance chambers for acoustic effects, or components of systems designed to manipulate physical forces in ways we don't yet understand. The precise positioning of underground features relative to the pyramid's internal structure suggests that their designers understood principles of engineering and physics that we're only beginning to appreciate. This technological interpretation remains highly controversial within mainstream archaeology, but the sophistication revealed by the Muon scans makes it increasingly difficult to dismiss entirely. The level of planning, precision, and engineering capability required to create the underground complex forces us to acknowledge that the pyramid's builders possess knowledge and skills that we've seriously underestimated. The question becomes not whether ancient Egyptians could have incorporated advanced technology into their monuments, but what form that technology might have taken and how it might have functioned. The underground network provides tantalizing clues, but we'll need much more detailed investigation before we can begin to understand what those clues might mean. For now, we're left with images created by cosmic radiation, ghostly outlines of chambers and passages that have remained sealed for over 4,000 years. Each Muon that passes through those hidden spaces carries information about architecture and engineering that challenges our fundamental assumptions about what ancient civilizations could accomplish. The discovery of this underground labyrinth represents just the beginning of what promises to be a complete revolution in our understanding of the Great Pyramid and ancient Egyptian capabilities. As scanning technology continues to improve and our analysis of the Muon data becomes more sophisticated, we may discover additional features and complexities that we haven't yet detected. More importantly, similar investigations could be conducted at other ancient sites around the world. Many monuments and complexes that we think we understand completely might be hiding underground components that we've never suspected. The Great Pyramid's hidden labyrinth might be just the first of many such discoveries that will transform our understanding of human history. But perhaps the most profound implication of this discovery isn't what it tells us about ancient technology or engineering capabilities. It's what it reveals about the scope of human ambition and vision when we commit ourselves to truly monumental goals. The people who created this underground network weren't content to build just another tomb or monument. They envisioned something unprecedented in scale and complexity, something that would integrate architecture, engineering, astronomy, acoustics, hydraulics, and spiritual symbolism into a unified masterpiece that spans multiple realms of existence. They thought beyond the limitations of their time and tools, pushing the boundaries of what was considered possible to create something that still challenges our understanding over 4,000 years later. They worked in secret, coordinating thousands of people in a construction effort that required decades to complete, all while maintaining absolute security about their true intentions. And they succeeded so completely that their hidden creation vanished from human knowledge until cosmic particles from deep space finally revealed its existence to our modern instruments. Somewhere in that labyrinth of stone and shadow lies evidence of human achievement on a scale we're only beginning to comprehend. The underground network beneath the Great Pyramid stands as proof that our ancestors were capable of far more than we've given them credit for. It challenges us to reconsider our assumptions about ancient capabilities and to ask what other secrets might be waiting for us to develop the technology and wisdom necessary to uncover them. Because ultimately, this discovery isn't just about the past, it's about the future and what becomes possible when human imagination, determination, and skill combine to attempt something that seems impossible. The ancient Egyptians who created this hidden masterpiece left us more than just buried chambers and forgotten passages. They left us an example of what we might accomplish when we dare to think beyond the accepted limits of what's possible and commit ourselves to making those impossible dreams into lasting reality. What makes this discovery even more extraordinary is what the Muon scans reveal about access and circulation patterns within the underground network. Because these weren't just random chambers carved into rock and then abandoned. The data suggests a sophisticated system of interconnected spaces designed for movement, with passages that branch and rejoin in patterns that speak to careful planning and ongoing use. The main arterial passages appear to follow a hub-and-spoke design, with major corridors radiating outward from central nodes like spokes on a wheel. But unlike simple radial patterns, these passages connect to each other through secondary corridors, creating loops and alternate routes that would allow for complex circulation patterns within the underground system. This type of design suggests that the ancient builders were thinking about traffic flow and crowd management in ways that wouldn't look out of place in modern urban planning. Multiple routes between key locations would prevent bottlenecks during ceremonies or other activities that brought large numbers of people into the underground spaces. But the circulation patterns also hint at something more intriguing than simple crowd control. The alternate routes and interconnected passages would have created opportunities for mystery and surprise within the underground experience. Initiates or participants in underground ceremonies could be led along different paths to reach the same destination, with each route providing different experiences or revealing different aspects of the complex's purpose. Some passages appear to include what researchers are calling pause points, small chambers or widened areas where groups could gather before continuing deeper into the system. These spaces might have served as checkpoints where participants' worthiness or preparation was evaluated before they were allowed to proceed further. The concept of graduated access aligns perfectly with what we know about ancient Egyptian mystery traditions. Sacred knowledge wasn't revealed all at once, but was transmitted through carefully structured progressions where each level of understanding had to be mastered before the next could be attempted. The underground network beneath the Great Pyramid might represent the physical manifestation of this pedagogical approach. Different chambers and passages could correspond to different levels of initiation, with the deepest and most sacred spaces reserved for only the most advanced practitioners. This interpretation gains support from the varying sizes and apparent functions of the detected chambers. Some spaces appear designed for individual contemplation or private instruction. Others could accommodate small groups for intermediate teachings. The largest chambers might have been used for communal ceremonies, involving dozens or even hundreds of participants. The Muon data also reveals what appear to be storage areas or repository chambers scattered throughout the network. These spaces are smaller than the main ceremonial chambers, but are positioned at strategic locations that suggest they held materials or objects needed for the activities taking place in nearby rooms. What might have been stored in these hidden repositories? The possibilities range from practical items like ceremonial tools, ritual clothing, and sacred texts, to more exotic materials that might have been considered too powerful or dangerous for surface storage. Ancient Egyptian religious practices involved numerous specialized objects and substances that were believed to possess magical or spiritual properties. Sacred oils, incense, amulets, ritual weapons, and preserved organic materials all played important roles in various ceremonies and magical workings. Some of these materials were considered so potent that they required special handling and storage conditions. Underground chambers would provide ideal environments for preserving such items, protecting them from temperature fluctuations, moisture, and unauthorized access, while keeping them readily available when needed. But the storage chambers might have contained more than just ceremonial objects. Recent research has revealed that ancient Egyptian priests and scholars were sophisticated natural philosophers who conducted what we would recognize today as scientific experiments and observations. They studied astronomy, mathematics, medicine, chemistry, and engineering with a rigor that rivals modern scientific methods. Their discoveries and accumulated knowledge were recorded in texts and preserved in temple libraries that served as the ancient equivalent of research institutions. Could some of the underground storage chambers have housed the most advanced and secret knowledge of ancient Egyptian science? Texts describing engineering techniques, astronomical observations, mathematical principles, or natural phenomena that were considered too sensitive for general circulation. The idea of hidden scientific knowledge isn't as far-fetched as it might initially seem. Throughout history, advanced knowledge has often been restricted to small groups of specialists who controlled its transmission and application. The underground network would provide perfect conditions for preserving and protecting such materials. The environmental stability of the sealed chambers would protect papyrus scrolls, wooden tablets, and other fragile materials that would have decayed long ago in surface conditions. The security provided by the hidden location would prevent the knowledge from falling into inappropriate hands or being lost during political upheavals. If such scientific archives exist within the underground complex, their discovery would revolutionize our understanding of ancient Egyptian capabilities and knowledge. We might find evidence of astronomical observations that predate known records by centuries, mathematical principles that weren't supposed to be discovered until much later periods, or engineering techniques that explain how impossible construction projects were actually accomplished. The potential implications extend far beyond Egyptology. Advanced ancient knowledge could provide insights into historical questions that have puzzled researchers for generations. It might reveal connections between different ancient civilizations that we haven't previously recognized, or demonstrate that certain scientific discoveries have much deeper historical roots than we currently believe. But the storage chambers might contain something even more intriguing than scientific texts or ceremonial objects. The Muon scans suggest that some repository spaces are positioned at locations that correspond to specific astronomical alignments or geometric relationships within the overall complex. These special positions hint that certain stored materials might have been integral to whatever technological or spiritual functions the underground network was designed to serve. Rather than passive storage, these chambers might have housed active components of systems that we don't yet understand. The ancient Egyptians were master engineers who understood principles of mechanics, hydraulics, and materials science that enabled them to create machines and devices of remarkable sophistication. Archaeological evidence has revealed examples of ancient Egyptian mechanical devices that operated through ingenious applications of leverage, counterweights, water pressure, and other physical principles. Could the underground complex include similar mechanical systems, with some of the detected chambers housing the machinery needed to operate them? The environmental stability of the sealed spaces would provide ideal conditions for preserving metal components, wooden mechanisms, and other mechanical elements that would have corroded or decayed in surface conditions. The regular spacing of certain features detected in the Muon scans could represent the placement of mechanical installations rather than just architectural elements. If the underground network included moving parts, automated systems, or other dynamic components, their positions would need to be carefully coordinated to ensure proper operation. This mechanical interpretation becomes more plausible when we consider the sophisticated engineering evident throughout the underground complex. The precision of the construction, the integration with surface features, and the apparent coordination of multiple subsystems all suggest capabilities that go well beyond simple stone carving and chamber excavation. The ancient builders clearly understood principles of structural engineering, water management, ventilation design, and acoustic control. Applying similar engineering knowledge to mechanical systems would represent a logical extension of their demonstrated capabilities. But whether the underground chambers contain scientific archives, mechanical devices, ceremonial objects, or something else entirely, their discovery has already begun to transform our understanding of what ancient civilizations could accomplish when they committed to truly ambitious projects. The scale and sophistication of the underground network forces us to acknowledge that we've been thinking too small about ancient Egyptian capabilities. These weren't primitive people struggling with basic construction challenges. They were sophisticated engineers, architects, and planners capable of conceiving and executing projects that rival anything we might attempt today. More importantly, they were visionaries who thought beyond the immediate requirements of their time and culture. The underground complex wasn't created just to serve the burial needs of a single pharaoh. It was designed as a lasting installation that could continue functioning for centuries or millennia, serving purposes that extended far beyond any individual ruler's lifetime. This long-term perspective reveals something profound about ancient Egyptian civilization that we're only beginning to appreciate. They weren't just building for their own generation or even for their immediate descendants. They were creating installations designed to serve humanity across vast spans of time, preserving knowledge, capabilities, and spiritual traditions that they believed would be needed by future generations. The underground labyrinth beneath the Great Pyramid represents perhaps the ultimate expression of this long-term thinking. Hidden from view, protected from interference, and designed to endure for millennia, it stands as a time capsule preserving the highest achievements of one of history's most remarkable civilizations. And somewhere in that network of passages and chambers, carved into living rock beneath humanity's most enigmatic monument, lies evidence that will continue reshaping our understanding of what's possible when human imagination, skill, and determination combine to attempt something that seems impossible. The Muon scans have given us our first glimpse into this hidden world, but they represent only the beginning of what promises to be one of the most significant archaeological investigations in human history. As our technology continues to advance and our analysis becomes more sophisticated, we may discover that the underground complex contains surprises that we haven't even begun to imagine. Because if there's one thing this discovery has taught us, it's that our ancestors were capable of far more than we've given them credit for. The underground labyrinth beneath the Great Pyramid stands as proof that the ancient world still holds secrets that could revolutionize our understanding of human history and capabilities. And the most exciting part is that we've only just begun to explore what those secrets might reveal. The question that haunts researchers as they study these Muon images isn't just what lies hidden in the depths, but how much more we might have missed. Because if an underground network this vast and sophisticated could remain completely undetected beneath the world's most studied monument for over 4,000 years, what else might be waiting for us to develop the right technology to see it? The implications ripple outward from Giza like stones thrown into still water. Every pyramid, every temple, every ancient site that we thought we understood completely might be hiding underground components that we've never suspected. The Muon scans of the Great Pyramid might represent just the first glimpse of a much larger pattern of hidden architecture that spans the ancient world. Consider the other pyramids at Giza. The Muon detection technology that revealed the underground labyrinth beneath Khufu's monument could just as easily be applied to the pyramids of Khafra and Menkaure. If similar underground networks exist beneath these structures, we might discover that the entire Giza complex was designed as an integrated system, spanning multiple monuments and extending deep into the bedrock beneath the plateau. The possibility becomes even more intriguing when we consider the Sphinx. This enigmatic monument has long been suspected of hiding chambers or passages within its body or beneath its base. Muon scanning could finally provide definitive answers about what, if anything, lies hidden within or beneath this ancient guardian. But the technology's potential extends far beyond Giza. Egypt contains dozens of other pyramid sites, hundreds of temples, and countless other monuments that could harbor similar secrets. Each site scanned with Muon detection technology might reveal new underground networks, hidden chambers, or architectural features that completely change our understanding of ancient Egyptian civilization. The broader implications are staggering. If underground construction was a standard feature of major ancient Egyptian monuments, then we've been studying only the visible portions of complex systems that extend deep into the earth. Our understanding of ancient Egyptian architecture, engineering, and religious practices might need to be completely reconsidered in light of these hidden dimensions. The technology could also be applied to ancient sites in other parts of the world. Many civilizations built monuments and complexes that might include underground components we've never detected. The megaliths of Stonehenge, the temples of Angkor Wat, the ruins of Machu Picchu, the pyramids of Mexico and Central America. All of these sites and countless others could potentially harbor hidden networks similar to what we've discovered beneath the Great Pyramid. Each new application of Muon detection technology might reveal that our ancestors were even more ambitious and capable than we've realized. The underground labyrinth beneath the Great Pyramid might not be unique, but rather typical of how ancient civilizations approach major construction projects. This possibility forces us to confront an uncomfortable truth about modern archaeology. Despite decades of excavation, survey, and analysis, we might have been missing crucial components of the very sites we thought we understood best. The visible ruins and monuments we've studied so intensively might represent only the tip of much larger icebergs of ancient construction. The implications for historical interpretation are profound. If major ancient sites routinely included extensive underground components, then our understanding of their original purposes, functions, and significance might be fundamentally incomplete. We might have been trying to understand complex integrated systems while seeing only small portions of their total design. Take, for example, our understanding of ancient religious practices. If temples and sacred sites routinely included underground spaces for ceremonies, initiations, or other spiritual activities, then the religious life of ancient civilizations might have been far more complex and sophisticated than we've realized. The underground chambers might have hosted mystery traditions, esoteric teachings, or spiritual practices that were never recorded in surface inscriptions or surviving texts. These hidden dimensions of ancient religion could represent some of the most important and influential aspects of ancient spiritual life, yet they've remained completely unknown to modern scholars. Similarly, our understanding of ancient science and technology might need major revision if underground installations were used for scientific observations, experiments, or the preservation of advanced knowledge. The sophisticated engineering evident in the Great Pyramid's underground network suggests capabilities that we've seriously underestimated. If similar installations exist at other ancient sites, we might discover evidence of scientific and technological achievements that predate known historical records by centuries or millennia. Ancient civilizations might have possessed knowledge of astronomy, mathematics, engineering, and natural science that we've never suspected. The social and political implications are equally significant. The coordination and secrecy required to construct underground networks like the one beneath the Great Pyramid suggest levels of organizational capability and social control that challenge our understanding of ancient governmental and religious institutions. If such hidden construction was common, it implies that ancient civilizations possessed sophisticated systems for managing classified information, coordinating complex projects across extended time periods, and maintaining operational security on scales that rival modern intelligence operations. These capabilities suggest that ancient societies were far more complex and sophisticated than we've typically assumed. They weren't just collections of farmers and craftspeople led by powerful rulers. They were advanced civilizations with institutional structures, technological capabilities, and organizational systems that enabled them to undertake projects of extraordinary ambition and complexity. The discovery also raises questions about information transmission across historical periods. If ancient civilizations possessed advanced knowledge and capabilities that were deliberately hidden or restricted to small groups of specialists, how much of that information survived into later periods? Medieval and Renaissance scholars had access to ancient texts and traditions that are now lost to us. Some of the knowledge and capabilities evident in ancient underground construction might have been transmitted through secret scholarly traditions that preserved and protected it across centuries of political and social upheaval. The underground network beneath the Great Pyramid might represent just one example of ancient knowledge that was deliberately hidden to protect it from destruction or misuse. Similar installations at other sites might have served as repositories for different types of knowledge or capabilities, creating a distributed archive of ancient wisdom that we're only beginning to discover. But perhaps the most profound implication of this discovery is what it reveals about the scope of human potential when we commit ourselves to truly monumental goals. The people who created the underground labyrinth beneath the Great Pyramid weren't content with ordinary achievements. They envisioned something unprecedented and then found ways to make it reality. They overcame technical challenges that would be difficult even with modern tools and methods. They coordinated complex projects across decades of construction while maintaining absolute secrecy about their true scope and purpose. They created installations designed to function for millennia, serving purposes that extended far beyond their own lifetimes. Most importantly, they succeeded so completely that their achievements remained hidden until cosmic particles from deep space finally revealed their existence to our modern instruments. The underground network stands as proof that human imagination, skill, and determination can accomplish things that seem impossible to later generations. The Muon scans have given us our first glimpse into this hidden world, but they represent only the beginning of what promises to be a complete revolution in our understanding of ancient civilizations and human capabilities. As scanning technology continues to improve and similar investigations are conducted at other ancient sites, we may discover that the underground labyrinth beneath the Great Pyramid is just one example of a much broader pattern of hidden achievement. Because somewhere in the depths beneath our most ancient monuments, carved into living rock and sealed away from human sight for thousands of years, lies evidence of what becomes possible when we dare to think beyond the accepted limits of our time and commit ourselves to making impossible dreams into lasting reality. The underground network beneath the Great Pyramid challenges us to reconsider not just what ancient civilizations accomplished, but what we ourselves might achieve if we approach our own challenges with similar vision, determination, and willingness to attempt what seems impossible. In the end, the most important discovery beneath the Great Pyramid might not be any specific chamber, passage, or artifact. It might be the reminder that human potential has no limits except those we accept, and that the greatest achievements in history have always belonged to those who dared to see beyond the boundaries of what their contemporaries believed was possible. That lesson, carved in stone and hidden in darkness for over 4,000 years, might be the most valuable treasure waiting for us in the labyrinth beneath the Great Pyramid. The deeper we examine these Muon readings, the more we realize we're looking at something that defies every assumption about how ancient monuments were supposed to function. Because what we're seeing isn't just impressive engineering or remarkable construction techniques. We're looking at evidence of planning and foresight that operated on timescales we can barely comprehend. Think about what it means to design a structure intended to function for thousands of years. Every component, every passage, every chamber had to be conceived not just for immediate use, but for continuous operation across centuries of political upheaval, climate change, and social transformation. The ancient builders weren't just thinking about their own generation. They were engineering for eternity. This long-term perspective appears throughout the underground network in ways that become more apparent as we study the Muon data in greater detail. The passages aren't just carved through rock. They're carved through specific types of rock chosen for their stability and resistance to geological shifts. The chambers aren't just hollowed-out spaces. They're positioned at locations where natural geological forces would provide maximum structural support over extended periods. Even the water management systems detected in the scans show this same forward-thinking approach. The channels and drainage features aren't designed just to handle normal groundwater flow. They're engineered to cope with extreme conditions that might occur only once every few centuries: massive storms, seismic shifts, or changes in the regional water table that could threaten the entire complex. But perhaps the most striking evidence of this long-term planning appears in what researchers are calling the maintenance access system. Scattered throughout the underground network are narrow passages that don't seem to serve any ceremonial or storage function. Instead, they appear designed to provide access for inspection and repair of the main chambers and corridors. The implications are staggering. The ancient Egyptians didn't just build this underground complex and then seal it away forever. They created a system that could be maintained and serviced across generations, with hidden access routes that would allow caretakers to enter the network, perform necessary repairs, and exit without disturbing the primary functions of the installation. This suggests an institutional continuity that we've never fully appreciated in ancient Egyptian civilization. Maintaining an underground complex for centuries would require not just technical knowledge, but organizational structures capable of preserving specialized skills and responsibilities across multiple generations of caretakers. The maintenance passages also hint at something even more intriguing. If the underground network required ongoing care and attention, it means the system wasn't just a static monument or tomb. It was an active installation that continued to serve important functions long after its initial construction was completed. What kind of functions would require such long-term maintenance? The answer might lie in the unusual features that keep appearing in the Muon data, anomalies that don't match typical stone architecture, but suggest the presence of systems or installations that we don't yet understand. Some of these anomalies appear to be connected to the water management features detected throughout the complex. But instead of simple drainage or storage, the patterns suggest active water circulation systems that might have required periodic adjustment or repair to continue functioning properly. Ancient Egyptian engineers were masters of hydraulic systems that used natural forces to move water through complex networks of channels, pools, and reservoirs. The underground complex might have included similar systems operating on a scale and level of sophistication that surpasses anything we've discovered at surface sites. But water circulation might have served purposes beyond just practical engineering considerations. In ancient Egyptian religious thought, flowing water wasn't just a physical phenomenon. It was a spiritual force that connected the material world to divine realms. Sacred pools and channels in temple complexes weren't just decorative features. They were functional elements of religious systems that used water flow to create spiritual environments suitable for communion with gods and ancestors. The underground network might have included the most sophisticated example of such sacred hydraulic engineering ever created. The maintenance access system would have been essential for keeping these water features functioning properly across centuries of use. Channels could become blocked with sediment. Pools might require cleaning or ritual purification. The delicate balance of flows and pressures that kept the system operating would need constant monitoring and occasional adjustment. But the maintenance passages might have served another purpose that goes to the heart of why this entire complex was created in the first place. Because if the underground network was designed to serve spiritual or ceremonial functions that continued across generations, then access for priests, initiates, or other religious personnel would have been essential for its ongoing operation. The narrow maintenance passages might have doubled as discrete entry routes that allowed authorized individuals to enter the underground spaces without drawing attention from the outside world. The secrecy that surrounded the complex during its construction might have continued throughout its operational lifetime, with only select members of the priesthood aware of its existence and purpose. This interpretation gains support from what we know about ancient Egyptian temple operations. Major religious institutions included inner sanctuaries and restricted areas that were accessible only to high-ranking priests who had undergone special training and purification rituals. The underground complex might represent the ultimate expression of this hierarchical approach to sacred space. The maintenance access system would have allowed these authorized personnel to enter the underground network, perform whatever ceremonies or functions were required, and then exit without leaving any surface evidence of their activities. To outside observers, the pyramid would appear to be a static monument, while hidden below, an active spiritual installation continued to serve its intended purposes. The sophistication of this concealed operation becomes even more impressive when we consider the logistical challenges involved. Maintaining an underground complex in complete secrecy would require not just physical access routes, but also systems for transporting materials, removing waste, and coordinating activities without detection. The Muon scans hint at features that might represent elements of such logistical systems. Some passages appear to include widened areas that could have served as storage alcoves or staging points for materials and equipment. Other corridors show internal structures that might represent mechanical installations for moving heavy objects through the underground network. But the most intriguing aspect of the maintenance system might be what it tells us about the knowledge and skills that were preserved within ancient Egyptian religious institutions. Keeping the underground complex operational across centuries would have required detailed technical knowledge about its construction, function, and repair requirements. This knowledge would have been too complex and specialized to transmit through normal teaching methods. It would have required dedicated training programs, detailed documentation, and institutional structures capable of preserving technical expertise across multiple generations of practitioners. The underground network might have served as more than just a spiritual installation. It might have been a repository for advanced engineering knowledge that was considered too sensitive or valuable to risk losing through normal historical processes. The maintenance requirements would have ensured that this knowledge remained active and current, rather than becoming fossilized in static records. This interpretation suggests that ancient Egyptian religious institutions served functions that we've never fully appreciated. They weren't just centers for worship and ceremony. They were also advanced technical institutions that preserved and transmitted specialized knowledge across vast spans of time. The priests who maintained the underground complex would have been engineers, hydraulic specialists, and systems managers as much as religious functionaries. Their training would have included not just theological and ceremonial knowledge, but also advanced technical education in fields that we're only beginning to understand. The implications ripple outward from the underground network to encompass our entire understanding of how knowledge was preserved and transmitted in the ancient world. If major religious institutions routinely maintained hidden technical installations, then the apparent loss of ancient scientific and engineering knowledge might not have been as complete as we've assumed. Advanced capabilities might have survived within secret institutional traditions long after they disappeared from public knowledge. The underground maintenance system suggests that such traditions could have operated continuously for centuries, preserving technical knowledge that mainstream history assumed was lost forever. But the maintenance access system also raises profound questions about what we might find if we ever succeed in physically exploring the underground complex. If the network remained active for extended periods after its initial construction, then the chambers and passages might contain evidence of this continued use. We might discover tools, equipment, or materials left behind by ancient maintenance crews. We might find inscriptions, records, or documentation related to the complex's operation and upkeep. Most intriguingly, we might uncover evidence of modifications, upgrades, or expansions that were made to the original system across centuries of use. Such evidence would provide unprecedented insights into how ancient Egyptian technology and knowledge evolved over time. Instead of seeing only static snapshots from specific historical moments, we might be able to trace the development of advanced capabilities across extended periods. The underground network might contain a complete archive of ancient Egyptian technical achievement, preserved not in written records, but in the physical modifications and improvements made to the installation across generations of use. Each maintenance intervention, each system upgrade, each adaptation to changing conditions would leave traces that could be read like pages in a book of ancient engineering history. But perhaps the most profound implication of the maintenance system isn't what it tells us about ancient technology or institutional continuity. It's what it reveals about the mindset and values of the people who created this underground masterpiece. They weren't building just for themselves or even just for their immediate descendants. They were creating something intended to serve humanity across vast spans of time, preserving capabilities and knowledge that they believed would be needed by future generations they would never meet. This perspective represents a form of intergenerational responsibility that seems almost foreign to our modern world. The ancient builders committed enormous resources and effort to creating systems that wouldn't reach full maturity for centuries after their own deaths. They invested in futures they would never see, guided by values that transcended their own immediate interests. The maintenance access system stands as physical proof of this remarkable commitment. Every narrow passage, every hidden access route, every carefully concealed entry point represents a bridge across time, connecting ancient builders to future caretakers in an unbroken chain of responsibility and purpose. And somewhere in that network of passages and chambers, carved into living rock beneath humanity's most enigmatic monument, that chain continues. The Muon scans have revealed its existence, but the underground labyrinth still guards its secrets, waiting for us to develop not just the technology to reach it, but the wisdom to understand what we'll find when we finally make contact with this ancient legacy. Because ultimately, the underground network beneath the Great Pyramid isn't just about ancient Egypt or even about archaeology. It's about the fundamental human capacity to think beyond our own lifetimes, to create things that serve purposes larger than ourselves, and to leave legacies that continue inspiring and challenging future generations long after we're gone. The maintenance passages remind us that the greatest achievements in human history have always belonged to those who built not just for today, but for tomorrow and all the tomorrows that would follow. The ancient Egyptians who created this hidden masterpiece understood something that we're still learning, that true immortality isn't achieved through monuments to ourselves, but through gifts we leave for those who come after us. That lesson, preserved in stone and silence for over 4,000 years, might be the most valuable discovery waiting for us in the depths beneath the Great Pyramid. And it's a lesson that becomes more relevant, not less, as we face our own challenges and consider what legacies we want to leave for the generations who will inherit the world we're creating today. The Muon scans have given us a glimpse into this ancient vision of intergenerational responsibility. The question now is what we'll do with that glimpse, and whether we have the wisdom to learn from ancestors who understood that the greatest human achievements are those that continue serving humanity long after their creators have returned to dust. As we stand at this threshold of discovery, peering through cosmic radiation into chambers that have waited in darkness for millennia, we find ourselves confronting questions that extend far beyond archaeology or ancient history. The Muon scans of the Great Pyramid have revealed something that forces us to reconsider not just what we know about the past, but how we approach the unknown itself. Because what we're looking at in these ghostly images isn't just evidence of remarkable ancient engineering. We're seeing proof of human vision operating on scales that dwarf our modern conception of what's possible. The underground labyrinth represents something unprecedented in the archaeological record. A construction project that was conceived, planned, and executed across multiple generations, with each phase building toward a goal that none of the individual workers would live to see completed. The implications of this multi-generational approach to construction are staggering when we consider the level of coordination and institutional continuity it would have required. Modern construction projects that span more than a few years typically struggle with cost overruns, design changes, and technological obsolescence. Yet somehow, the ancient Egyptians managed to maintain consistent vision and execution across decades of underground excavation while simultaneously building the pyramid above. This suggests organizational capabilities and institutional structures that operated with a stability and longevity we rarely see in modern societies. The knowledge, skills, and commitment necessary to complete such a project would have needed to be transmitted faithfully from master to apprentice across multiple generations of workers, engineers, and supervisors. But the Muon data reveals something even more extraordinary about this ancient achievement. The underground network wasn't just built to last for generations, it was designed to function and evolve across centuries of use. The maintenance access system we've identified represents clear evidence that the complex was intended to be modified, upgraded, and adapted as circumstances changed and knowledge advanced. This adaptive approach to monumental construction challenges everything we thought we knew about ancient building practices. We typically think of ancient monuments as static creations, built once and then left unchanged until they eventually fell into ruin. But the Great Pyramid's underground network appears to have been designed as a living system, capable of growth and modification across vast spans of time. The technical sophistication required to create such an adaptive system boggles the mind. The ancient engineers would have needed to anticipate not just the immediate structural and functional requirements of their installation, but also the ways those requirements might change over decades or centuries of use. They would have needed to design expansion joints that could accommodate future additions without compromising existing structures. They would have needed to create modular systems that could be reconfigured or replaced as technology advanced or purposes evolved. Most remarkably, they would have needed to document all of this complexity in ways that future generations could understand and work with. The question of documentation becomes particularly intriguing when we consider how such complex technical knowledge could have been preserved and transmitted across the centuries during which the underground system remained active. Written records would have been vulnerable to loss, damage, or misinterpretation. Oral traditions might have preserved general principles, but would struggle with specific technical details. The answer might lie in the installation itself. The underground network might have been designed as its own documentation system, with architectural features, symbolic elements, and construction details that encoded the information necessary for its continued operation and maintenance. This concept of architecture as information storage isn't without precedent in ancient cultures. Many traditional building techniques incorporate knowledge directly into structural elements, ensuring that essential information is preserved, even if written records are lost. The underground complex might represent the most sophisticated example of this approach ever created. If true, then every passage, chamber, and architectural detail we see in the Muon scans might carry multiple layers of meaning. Surface appearances might encode functional information about structural engineering, water management, or ventilation systems. Deeper symbolic patterns might preserve knowledge about astronomical alignments, mathematical principles, or religious concepts that were essential to the installation's operation. The maintenance crews who worked within the underground network across generations might have been trained not just as technicians, but as readers of this architectural language. Their ability to interpret the encoded information would have been essential for keeping the system functioning properly and making appropriate modifications as circumstances required. This interpretation transforms our understanding of ancient Egyptian civilization in profound ways. Instead of seeing a culture that relied primarily on written records and oral traditions for knowledge transmission, we might be looking at a society that developed sophisticated methods for encoding information directly into physical structures and systems. Such encoding techniques would have provided remarkable security and longevity for essential knowledge. Unlike written documents that could be stolen, destroyed, or corrupted, architectural encoding would be inherently difficult to separate from the structures themselves. The knowledge would survive as long as the buildings remained intact. But architectural encoding would also have required extraordinary levels of technical sophistication and cultural coordination. Developing symbolic systems complex enough to encode detailed technical information would have demanded advances in mathematics, linguistics, and design theory that we're only beginning to appreciate. Implementing such systems across large construction projects would have required standardized training programs, quality control procedures, and institutional structures capable of maintaining consistency across multiple generations of builders and craftsmen. The underground network beneath the Great Pyramid might represent the culmination of centuries of development in these architectural encoding techniques. The complexity and sophistication evident in the Muon scans could reflect not just the ambitions of a single pharaoh or architect, but the accumulated knowledge and capabilities of an entire civilization working at the height of its technical and cultural development. This perspective raises fascinating questions about what other ancient sites might contain similar encoded information systems. If architectural encoding was a standard practice in ancient Egyptian construction, then every temple, tomb, and monument might be preserving knowledge that we've never learned to read properly. The hieroglyphic inscriptions and artistic decorations that cover Egyptian monuments might be just the surface layer of much deeper information systems. The structural elements, proportional relationships, and spatial organizations that we typically analyze only for their aesthetic or functional properties might actually be sophisticated data storage systems, preserving knowledge that their creators considered too valuable to risk losing. Deciphering such architectural encoding would require new approaches that combine archaeological investigation with advanced mathematical analysis, computer modeling, and pattern recognition techniques. We might need to develop entirely new fields of study that bridge the gap between ancient history and information science. But the potential rewards would justify the effort. If we could learn to read the architectural languages used by ancient civilizations, we might discover that they preserved far more knowledge than we ever suspected. Technical information about engineering, astronomy, mathematics, and natural science might be hidden in plain sight, within monuments we've studied for generations without recognizing their true significance. The underground network revealed by the Muon scans might be our first glimpse into this hidden world of ancient information systems. The passages and chambers we see in the ghostly images might represent the most sophisticated example of architectural encoding ever created, preserving knowledge that could revolutionize our understanding of human history and capabilities. But to unlock that knowledge, we'll need to approach it with the same long-term vision and institutional commitment that the ancient builders brought to its creation. The underground complex wasn't built for immediate gratification or quick answers. It was designed to reward patient study and careful analysis conducted across the extended time periods necessary to fully understand its complexity. This requirement for patience and persistence might be the most important lesson the ancient builders left for us. In our modern world of rapid technological change and instant information access, we've become accustomed to expecting quick results from our investigations and research efforts. But the greatest discoveries in human history have always required sustained effort across extended periods. The underground labyrinth beneath the Great Pyramid represents a challenge that will demand the best of our scientific capabilities, technological resources, and institutional commitment across multiple generations of researchers. The Muon scans have given us our first glimpse into this ancient masterpiece, but they represent only the beginning of what promises to be one of the longest and most complex archaeological investigations ever undertaken. We're not just studying a monument from the past. We're engaging with a system that was designed to communicate across vast spans of time with civilizations its creators could barely imagine. The success of that communication will depend not just on our technological capabilities, but on our willingness to approach the underground network with the respect, patience, and long-term commitment that its creation required. The ancient builders invested centuries in creating their hidden masterpiece. Understanding it fully will require a similar investment from us, but the potential rewards extend far beyond archaeological knowledge or historical understanding. The underground network represents proof that human vision, determination, and technical capability can accomplish things that seem impossible to later generations. It stands as inspiration for what we ourselves might achieve if we're willing to think beyond the accepted limits of our time and commit to goals that transcend our own immediate interests. The Muon scans have revealed the existence of this ancient vision, made manifest in stone and space. The question now is whether we have the wisdom and commitment to learn from it, and whether we're ready to undertake the patient, sustained effort that will be required to unlock the secrets it still guards in the darkness beneath the Great Pyramid. Because somewhere in that labyrinth of passages and chambers, carved into living rock and sealed away from human sight for over 4,000 years, lies evidence of what becomes possible when human imagination refuses to accept the limitations of the present and dares to build for eternity. The ancient Egyptians who created this underground masterpiece left us more than just buried chambers and forgotten corridors. They left us a challenge and an inspiration, carved in stone and preserved in silence, waiting for us to develop not just the technology to reach it, but the vision to understand what we'll find when we finally make contact with this ancient legacy of human achievement operating on scales we're only beginning to comprehend. The underground network beneath the Great Pyramid stands as proof that our ancestors were capable of far more than we've given them credit for, and as inspiration for what we ourselves might accomplish when we dare to think beyond the boundaries of what seems possible and commit ourselves to making impossible dreams into lasting reality. That lesson, hidden in darkness for over 4 millennia, might be the most valuable treasure waiting for us in the depths beneath humanity's most enigmatic monument. And it's a lesson that becomes more important, not less, as we face our own challenges and consider what legacies we want to leave for the generations who will inherit the world we're creating today. The muon detection technology that revealed this underground labyrinth has opened a door that can never be closed again. Because once you've seen evidence of construction on this scale hidden beneath one of the world's most studied monuments, you can't help but wonder what else we've been missing. What other secrets lie buried beneath sites we thought we understood completely? The scanning process that uncovered the network beneath the Great Pyramid wasn't quick or simple. The detectors had to operate continuously for over 18 months, recording millions of individual particle interactions before researchers had enough data to begin creating their three-dimensional maps. But that patience paid off in ways that exceed every expectation. What emerged from the computer analysis wasn't just evidence of empty spaces carved into rock. The data revealed architectural sophistication that rivals anything we see in the visible pyramid above. Passages with walls so smooth they appear almost machine-made. Chambers positioned with mathematical precision that suggest their builders understood geometric principles we're only rediscovering today. The integration between the surface monument and the underground complex becomes more remarkable the deeper we examine the data. These weren't separate construction projects that happened to occupy the same location. Every major feature of the pyramid above has a corresponding element in the network below, creating a unified three-dimensional design that spans both realms simultaneously. This unified approach challenges our fundamental assumptions about how ancient monuments were conceived and built. We've been studying the Great Pyramid for centuries as if it were primarily a structure that reaches upward toward the heavens. But the Muon scans reveal that it was always intended to extend downward into the earth with equal ambition and sophistication. The religious implications of this dual nature are profound. Ancient Egyptian cosmology described existence as spanning multiple interconnected realms: the sky above where gods resided, the earth's surface where the living dwelt, and the underworld below where souls journeyed toward rebirth. A monument that physically occupied all three realms would represent the ultimate expression of this spiritual understanding. But the underground network includes features that suggest purposes beyond ceremonial or symbolic functions. The water management systems detected throughout the complex appear designed for active circulation rather than simple drainage. The maintenance access routes imply ongoing operational requirements that would have continued long after the pyramid's initial construction was completed. These functional elements hint at something we've never considered before: that the Great Pyramid might have been designed as more than just a tomb or religious monument. It might have been conceived as a type of ancient machine, using principles of physics and engineering that we're only beginning to understand. Recent research has revealed that the Great Pyramid exhibits unusual electromagnetic properties that scientists are still trying to explain. The monument seems to focus and concentrate electromagnetic energy in ways that suggest its builders possess knowledge of physical principles we've only recently rediscovered. If the pyramid was indeed designed to function as some type of technological system, then the underground network might be an integral part of that system. The passages and chambers could serve as conduits for electromagnetic energy, resonance chambers for acoustic effects, or components of installations designed to manipulate physical forces in ways we don't yet comprehend. The precision required to create such a system would have demanded not just advanced engineering knowledge, but also sophisticated understanding of mathematics, astronomy, and natural science. The ancient builders would have needed to coordinate multiple complex subsystems while maintaining exact alignments and measurements across the entire installation. Yet somehow they accomplished all of this using Bronze Age tools and techniques, working in conditions that modern safety standards would never permit. The logistics alone are staggering when you consider that the underground excavation would have generated millions of cubic meters of debris that somehow had to be removed without leaving any surface evidence of the work. The ancient Egyptians would have needed systems for lighting the work areas, ventilating the spaces to provide breathable air, and moving materials and workers through narrow passages that extended hundreds of meters into solid rock. They would have required surveying techniques precise enough to ensure that passages carved from different access points would meet exactly at their intended intersections. The fact that they achieved all of this while maintaining absolute secrecy about the project suggests organizational capabilities that we've seriously underestimated. Knowledge of the underground construction would have been restricted to a very small group of individuals at the highest levels of Egyptian society, with elaborate security measures to prevent information from leaking to unauthorized personnel. This level of operational security implies institutional structures and management systems that rival modern intelligence operations in their sophistication and effectiveness. The ancient Egyptians weren't just skilled craftsmen following traditional building methods. They were sophisticated project managers capable of coordinating complex operations across extended time periods while maintaining strict information control. The success of their security measures is evident in the fact that knowledge of the underground network was so completely erased from historical memory that it remained hidden until cosmic particles from deep space finally revealed its existence to our modern instruments. No contemporary records describe the underground construction. No ancient texts mention the hidden passages and chambers. No tomb paintings depict workers laboring in the depths beneath the pyramid. This deliberate concealment raises fundamental questions about the true purpose of what lies beneath. If the underground complex was simply an extension of burial arrangements for Pharaoh Khufu, why hide it so completely? Royal tombs were typically celebrated and documented, not erased from memory. The pharaoh's journey to the afterlife was usually a public concern involving elaborate ceremonies that the entire kingdom participated in. The complete secrecy surrounding the underground network suggests it served purposes that couldn't be shared with the general population or even with most members of the royal court. Whatever functions the hidden chambers were designed to fulfill, they were considered so sensitive or sacred that knowledge of their existence had to be protected at all costs. This interpretation gains support from the apparent sophistication of the access control systems detected in the Muon scans. The underground network wasn't designed for casual entry or public visitation. The narrow maintenance passages and hidden entry routes suggest that access was strictly limited to authorized personnel who possessed specialized knowledge about the complex's layout and operation. Such restricted access would have been essential if the underground chambers housed advanced technologies, sacred knowledge, or spiritual practices that were considered too powerful or dangerous for general circulation. Ancient Egyptian religious traditions included mystery schools, where esoteric teachings were revealed only to carefully selected initiates who had proven their worthiness through elaborate preparation and testing. The underground complex might have served as the ultimate mystery school, where the most profound secrets of Egyptian spirituality and knowledge were preserved and transmitted to successive generations of initiates. The journey through dark passages to reach hidden chambers would provide powerful metaphors for the spiritual transformation that such initiation was meant to produce. The acoustic properties of the underground spaces would have enhanced these initiatory experiences in ways that surface installations couldn't match. Sound behaves differently in enclosed stone chambers, creating resonances and echoes that can produce profound psychological effects on listeners. Chanting, music, or spoken teachings would be transformed by the underground architecture, creating otherworldly atmospheres that reinforce the sacred nature of whatever knowledge was being transmitted. But the underground network might have preserved more than just spiritual teachings. If ancient Egyptian civilization possessed advanced scientific or technical knowledge that was considered too sensitive for public circulation, the hidden chambers would have provided ideal conditions for its preservation and protection. The environmental stability of sealed underground spaces would protect fragile materials like papyrus scrolls, wooden tablets, or metal objects that would have decayed long ago in surface conditions. The security provided by the hidden location would prevent valuable knowledge from being lost during political upheavals, foreign invasions, or social disruptions that periodically affected Egyptian civilization. If such knowledge archives exist within the underground complex, their discovery would revolutionize our understanding of ancient Egyptian capabilities and achievements. We might find evidence of astronomical observations, mathematical principles, engineering techniques, or natural science discoveries that predate known historical records by centuries. The implications would extend far beyond Egyptology to encompass our entire understanding of how human knowledge and capability have developed across history. Advanced ancient knowledge could provide insights into historical questions that have puzzled researchers for generations, or reveal connections between different ancient civilizations that we haven't previously recognized. But accessing such knowledge would require approaches very different from traditional archaeological methods. The underground chambers have remained sealed for over 4,000 years, preserving whatever lies within them in pristine condition. Any attempt to enter these spaces physically would inevitably introduce contamination and risk destroying priceless evidence that has survived intact for millennia. The solution might lie in developing new technologies that can explore and document the underground spaces without requiring human presence or physical disturbance. Advanced robotic systems equipped with sophisticated sensors could navigate the passages and chambers while leaving them essentially undisturbed, creating detailed records of everything they encounter without compromising the preservation conditions that have protected these spaces for so long. Such robotic exploration would represent a new frontier in archaeological investigation, where digital preservation replaces physical collection, and virtual museums document spaces that remain forever sealed. The technological challenges would be immense, but the potential rewards justify whatever investment might be required to develop the necessary capabilities. Because somewhere in that network of passages and chambers, carved into living rock beneath humanity's most enigmatic monument, lies evidence that could transform our understanding of what ancient civilizations accomplished and what human potential can achieve when guided by vision, determination, and commitment to goals that transcend individual lifetimes. The Muon scans have given us our first glimpse into this hidden world, but they represent only the beginning of what promises to be one of the most significant archaeological discoveries in human history. As our technology continues to advance, and our analysis becomes more sophisticated, we may find that the underground labyrinth contains secrets that we haven't even begun to imagine. And that's perhaps the most exciting aspect of this entire discovery. The recognition that after thousands of years of study, the Great Pyramid still has the power to surprise us, to challenge our assumptions, and to remind us that human achievement has always been capable of reaching heights we can barely comprehend. The ancient builders who created this underground masterpiece left us more than just hidden chambers and forgotten passages. They left us proof that the impossible becomes possible when human imagination refuses to accept the limitations of the present and commits to building something that will serve purposes greater than any individual lifetime. That lesson, preserved in stone and silence beneath the sands of Giza, continues to echo across the millennia, challenging us to consider what we ourselves might accomplish if we approached our own goals with similar vision and determination. The underground labyrinth beneath the Great Pyramid represents more than just an archaeological discovery. It stands as a testament to something we've almost forgotten in our modern world: the power of thinking beyond our own lifetimes, of building not just for today but for generations we'll never meet. When you really consider what the ancient Egyptians accomplished here, it's not just the engineering that takes your breath away, it's the audacity of their vision. Somewhere around 2580 BCE, a group of human beings looked at the bedrock beneath what would become the Great Pyramid and said, "We're going to carve an entire city down there. We're going to make it perfect, and we're going to hide it so well that it won't be discovered for over 4,000 years. That level of ambition, that commitment to secrecy, that willingness to invest decades of labor in something that might never be seen again, it reveals a mindset that's almost alien to how we approach problems today. We live in an age of instant gratification, of quarterly reports, of projects that need to show results within a few years or they get cancelled. But the people who created this underground network were playing a completely different game. They were thinking in terms of millennia, they were building for eternity, and they succeeded beyond anything we could have imagined. The Muon scans show us chambers that have remained untouched since the Old Kingdom, passages that have never felt a human footstep since their builders sealed them away. The precision, the planning, the sheer scale of what they accomplished, it forces us to confront an uncomfortable truth about our own limitations. We like to think we're more advanced than our ancestors. We have computers, satellites, nuclear power, genetic engineering. We can split atoms and sequence DNA and send robots to Mars. But could we build something like this underground labyrinth? Could we coordinate a secret construction project of this magnitude, maintain it across multiple generations, and then make it disappear so completely that it would remain hidden for 4 millennia? The honest answer is probably not. Our modern world is too connected, too transparent, too impatient for that kind of long-term secrecy and commitment. We can't even keep government secrets for more than a few years before someone leaks them to the press. But the ancient Egyptians managed to keep this secret for over 4,000 years. They created something so extraordinary that it challenges everything we thought we knew about their capabilities, and they did it without leaving a single trace in the historical record. That achievement puts our own accomplishments in perspective. Yes, we've split the atom and landed on the moon, but we've also created weapons that could destroy civilization, pollution that's changing the climate, and social media platforms that are tearing apart the fabric of civil discourse. The builders of the underground network left us something different. They left us proof that human beings are capable of creating things that endure, that serve purposes beyond profit or politics, that represent the very best of what we can accomplish when we commit ourselves to something greater than our own immediate interests. The question is whether we still have that capacity, whether we can learn from their example and apply it to the challenges we face today. Because the problems confronting our generation, climate change, resource depletion, social inequality, the risk of nuclear war, these are challenges that will require the same kind of long-term thinking and commitment that went into creating the underground labyrinth. We need to start thinking like the ancient Egyptian architects who planned for millennia rather than quarters. We need institutions that can maintain purpose and direction across multiple generations. We need the courage to undertake projects that might not pay off for decades or centuries, but that serve the long-term interests of humanity. The Muon scans have given us more than just images of hidden chambers. They've given us a mirror that reflects our own potential and our own limitations. They've shown us what becomes possible when human vision operates on timescales that transcend individual lifetimes. The underground network beneath the Great Pyramid will continue revealing its secrets as our technology improves and our understanding deepens. But the most important secret it's already revealed is this: we are capable of far more than we typically attempt. The boundaries we accept as fixed are often just limitations we've imposed on ourselves. The ancient builders who created this hidden masterpiece understood something we've forgotten: that the greatest human achievements are those that serve not just ourselves, but all the generations that will come after us. They built for eternity, and eternity has finally begun to reveal what they accomplished. The question now is, what we'll do with that revelation? Will we learn from their example and commit ourselves to projects that transcend our own lifetimes? Will we build institutions and undertake initiatives designed to serve humanity across centuries rather than just election cycles or business quarters? Or will we continue thinking small, limiting ourselves to goals we can accomplish within our own lifespans, leaving future generations to solve the problems we're creating today? The underground labyrinth beneath the Great Pyramid stands as both inspiration and challenge. It proves that extraordinary things become possible when we think beyond the accepted limits of our time. But it also challenges us to match that vision with our own commitment to building something that will endure. Somewhere in those hidden chambers, carved into living rock and sealed away from human sight for over 4 millennia, lies evidence of what we ourselves might accomplish if we had the courage to think as boldly as our ancestors did. The Muon scans have opened a door to that ancient vision. The question is whether we're ready to walk through it.